Welcome back, everyone. I hope everyone enjoyed the sessions this morning and the breakout sessions, and that you got a chance to network with the speakers and the other delegates. Our current session will be going through the ADIA Lab 2025 Structural Break Challenge Awards. This global challenge, hosted in partnership with Crunch Lab, received close to 9,000 entries from more than 1,800 participants around the world. These participants were competing for a total prize pot of $100,000 with a top prize of $40,000 for the overall winner. To talk a little bit about the challenge and to announce the winners for today, I invite John Norell, founder of our partners Crunch Lab, and Emanuele Olivetti, Quantitative Research and Development Lead at ADIA. Please welcome me and join them.
Good afternoon, everyone. Today we talk about the ADIA Lab Structural Break Challenge. As the past years, ADIA Lab is this tradition of having an international data science challenge that stimulates a large audience to participate into the activity of ADIA Lab, into these pillars, and to engage into a single problem, a simple problem, a deceptively simple problem that for months is addressed by many participants and many submissions. I'm here speaking on behalf of many people, so it's not just my work. There is also Jean from Crunch Labs and his team. There is a lot of people from ADIA Lab, and Horst, Marcus, and Alex are the ones that are leading the way in this year competition because of the formulation of the problem. It's a problem of interest for ADIA Lab pillars, and together with myself, Vincent, Patrick, that are here in the audience, Roman, Koshik, that I've seen him around as well, we worked on the formulation of this problem, on setting up something that can, let's say, attract people to work intensely on this problem that can be applied in multiple fields of application. So after this talk, if you want to know more, you can find them inside the audience and you can talk to them as you can talk to me. So what is a structural break? Imagine a time series. This could be a reading of a sensor, this could be a stock price, this could be a temperature that you measure in Abu Dhabi over time. And then at a certain point, this is the first part of the measurement over time, when there is that red line, at a certain point, you look at the second part of the recording. And what happens? This second part may seem similar or different to the first part. And is the second part structurally different from the first part? Is the nature of the process that we are observing different or not? It's difficult to say. So this is the actual definition, practical definition. I will give multiple ones of structural break. Okay. Let me give you a bit of context on this very simple example. This is a super simple random walk. Some in the audience would call it Brownian motion or Wiener process, depends on your community. It's just a very simple equation. It has some parameters, 2, mu and sigma. Drift and volatility depends on your community. And then at a certain point, at that point, I change those values from 0.1 and 1 to minus 0.1 and 2. And so the process had another trajectory. It's a stochastic trajectory. That is just one realization of what it could be. If I hadn't changed these values, the process would have continued in one realization across the blue line. So I made an intervention, I made a change. Something happened that changed the nature of the process. And this created a structural break, a different behavior. But if you look back at the problem, it's not that easy to answer this question. It seems plausible. So the core of the challenge of this year ADIA Lab competition is exactly detecting when there is a structural break from when there is not. We see this problem in many domains of application. We see, for example, in climatology, if we monitor the temperature over the months, over the days, over the years in a location, we can see maybe that after a certain point, after the red line, there is a difference. Maybe, I don't know, in a neighboring area there was a volcano explosion. So the ashes goes into the atmosphere, filter the light in a different way. And then for the next years, we saw a slightly different measurement in temperature, even at that scale. Or there could be some climatology event like El Nino that creates these massive differences. But then, even if we go at the millisecond scale and we look in another field of application, which is the healthcare, if we look at, for example, the electrocardiogram, we can see that after a certain point, in some cases, we have a completely different we have a change in the system, in the heart, in the heart monitoring, in the potential of the heart that is different from before. And detecting this is very important. For example, when we monitor patients in ICU, in intensive care units, and also for, let's say, many other biological signals that we can think of. In finance, we have, for example, stock returns. There are events, we can call intervention events, like new tariffs, and then this creates turbulence on the market. And so we see very visibly in this case a remarkable difference between what happens after with what happened before. And in analyzing this difference that can take many shapes and ways, we have the concept of structural break. And the last example is in manufacturing. We can have an engine inside a system that has a sensor, for example, a temperature sensor, but it can be also a motion sensor. And then after a while, maybe there is something that breaks into that system. And we see, not immediately, because we cannot just, after the red line, one time step after, just decide whether there is a structural break or not. We need some data, some time. And if we are efficient, we catch very quickly that something happened to our system, and we can react on that. So the structural break challenge basically answers to this question, asks you to answer to this question. Is there a structural break from the red line on with respect to what has happened before? And of course, this is an uncomfortable question. It's not an easy question, as the meme said. As a definition, we were asked by many participants to have a clear definition that we gave, but of course it's not easy because the problem is very general. If we have just one specific definition, we will find immediately a solution to the problem. But the structural break is characterized by a change in the fundamental nature or parameters of the data generation process, if you have a data generation process. And by the way, we gave thousands of, let's say, examples also to learn from. So one thing is to give a generic definition, and that can be applied, but another one is to give examples. We also gave 10,000 examples of time series, saying for each of them whether there was a structural break after the red line or not. And this example creates an implicit definition of structural break. You can even learn from examples. We try to cover, of course, in building this example, many cases. And the competition is about predicting whether there is a structural break on a test set. So an unseen set of time series which the participants, through for their algorithms, because this is a code competition, can compute for each of them a probability whether there is a structural break or not. We have, in practice, then two test sets, a private one and a public one. The public one gives an answer immediately, a public answer to the participants, but may create overfit, something we want to really control because we know well of this problem. And then, at the very end of the competition, after the competition ends, so basically today, we publish what is the actual score, what is the leaderboard on this private part of the test set. And to address this problem, there is a quite generous total prize pool that is divided among the top 10 participants to the competition. This data set is important. The people that you have seen at the beginning mainly worked on this step. because the formulation of the problem, the quality of the data, the kind of structural breaks and dynamics that you can address, the richness of this data set is the strength of this competition, at least in organizing this competition. And so we think, Marcos, I was discussing with Marcos this morning, we think that this is the value that also other researchers can use in the future to study this problem that is omnipresent in so many fields. And in fact, this problem can be used and can be used to develop new algorithms even after the competition ends, because it's in the plans of the platform of Crunch Labs to reopen this competition exactly for this scientific purpose. So where do these time series come from? I will just quickly say something and then give time to Jean to go on in this presentation. So we went through different data sources, stochastic processes, real data, different ways to blend them together, but then in each of them we created an intervention. So our definition, our problem of structural break starts with the idea that something intervene in the system and change the system, something changing the nature of the system. In the beautiful visualization that you see on the right side, one of the many that especially Vincent that is here helps preparing, you see for each dot, each colored dot is one of the 10,000 time series that you have seen before. This is a representation. You take the time series, you extract some descriptors, some features. Later I will talk a bit more about that, but you can think like the mean, the average, and many other properties. And then you do a dimensionality reduction, specifically UMAP here. So you can try to represent every time series just as a couple of coordinates, as a dot in 2 dimensions. And if we color each of these dots with the mechanism that we used to create this time series and the structural break, or not the structural break, you end up with that figure. And you can see that, yes, there are some parts, like that purple island, the purple cluster on the right, that are sort of isolated from the rest of the time series, but basically almost everything else is a blend, which means we didn't have just sparse, different generators or systems to create this time series with a structural break, but a sort of a continuous that in some sense point to the generality of the problem, something with that we care a lot in this competition. And then on May 14, the competition started, but at this point I will give the clicker and the words to Jean.
Thank you so much, Emanuele. I am extremely proud to be able to collaborate with ADIA Lab on this problem. It's been 3 years that we've been working on what used to be my vision when I started Crunch Lab in 2020, 4 years ago. And we share this vision with ADIA Lab, which is, can we find new ways to organize intelligence? Can we coordinate minds, a vast network of minds that go deeper than a lab of maybe 10 or 100 people? Can we scale that process of collecting intelligence, harvesting more solutions and things with modern tools? And that's really what Crunch Lab is. What we do in this kind of tournament is that we tap into collective intelligence and we try to collect new ways to solve common scientific problem. Now, when we choose this problem, it's really important to ask ourselves the right question. We want to be as high as possible into the mathematic dependency, right? And that was something that was mentioned this morning, is that there is some problem that many fields in science have in common, right? And if you can solve this problem very high in the dependency tree, you can unlock many different fields. And so this is what Emanuele described. It's a problem that is common to many other fields. And so what we do here is we're going to define a problem, and then we're going to focus hundreds, if not thousands of minds on this very narrow problem, but if solved, can unlock many other solutions. And that's a very difficult problem, so I'm very lucky to be working with such an amazing a group of fellows and Nobel laureate and Turing Prize that are able to help us guide and find the right angles to just throw this computing power and this amount of brains to the right problem. So we worked on causality last year, we worked on Ranker algorithm, and this year we worked on time series. And so in a moment where science is really accelerating, where we see these new technologies happening, there is another interest in doing this kind of competition, is that you find the state of the art. So you find where are we currently? Because you will have a depth and breadth of research. You'll have 10,000 people trying to find the best solution. So it's also a coordination mechanism, right? It's how do you coordinate people to look and compete and look for new solution? Comes with AI agent, coordinate the agent together, use different type of LLMs, use different type of statistics methods, and compete for 6 months in order to find this edge. And that's really what happened during the last 6 months and what happened every time we work on a problem with ADIA Lab and at Crunch Lab. So I'm extremely proud to be doing this work because I think it will unlock many other innovations. So we've been extremely successful this year again. The numbers are extremely impressive. We had 1,842 participants. I think it's at least 2 times more than last year.
Oh, I guess we are more or less in the total participant. We are really on the trend, but in a number of submissions that you are showing in a minute, that is impressive because it's more than twice.
So we've not only attracted 1,800 minds to look at this problem for ADIA Lab, but we also collect different point of view from different countries. So we have people from more than 100 countries on Crunch Lab, and in this competition we had a lot of people from India, US, China, Europe, and Brazil and Canada.
And UAE.
And UAE, by the way, yeah.
It's pretty.
And so this is also important because when you try to find solution to problem, the multidisciplinary aspect of things is extremely important. Like, can we get novel view? Can we get people from other fields? Can we abstract the problem and get people from biology, statistics, mathematics, machine learning, autodidacts that learn data science with LLMs to look at this problem for us? That's what you want, this diversity. In terms of type of people, we had about 8%, so 9% of PhDs, about 30% of graduate, 20% of undergraduate, and 40% of people that were too shy to say with their level of study. But I guess that's kind of a competition hack, right? In terms of submission, this is really where we had a huge success. We collected almost 9,000 models, so 9,000 submissions. So you have 1,800 people that are trying everything in order to solve that problem in a very little amount of time, and they're going to browse everything that is possible, and they're going to apply all that things. That's the power of this community. And if by reopening this tournament, we're going to collect even more models, and we collect the latest techniques when we do that also. That's also what's extremely interesting, that you always know where the edge, where the state of the art is. And this is the kind of diversity that you can collect. But Emmanuel,
Okay, thank you. Yeah, this is a representation of the solution, the top submissions that on the last day, the participant decided to submit for the final leaderboard. So there's not all the 9,000, but basically describe the attempts, the code, the ideas that they used during the competition. What is interesting, how do we did that? Basically using large language models, we can look into the code, create readable summaries that are still too many, but then using again large language models, clustering algorithms, and low-dimensional projection, we can again create maps of topics that are across all the solutions that were submitted. What is interesting here, I will navigate you throughout this map, is that on the right you see in blue islands, statistical hypothesis testing approaches. In the center, a bit on the top, in that yellow island, yellow and pink, there is deep learning hybrid approaches. So these 2 islands are basically different from all the other ones. All the other solutions are all the other islands are just variation of one single approach. So to be successful in this competition, one approach was much better than the others. Despite 9,000 different attempts, we saw that extracting features, extracting many, many descriptors from this time series, and using traditional machine learning, so not even deep learning, which had a minor role in this competition, you could get the highest possible score in detecting structural breaks. And so you see feature engineering, feature-rich ensemble methods, statistical feature comparison. So you extract features, all these islands describe this same approach, and then using algorithms that, of course, are extremely powerful, like gradient boosting, random forest, tree-based methods that basically are able to put together the information in this, from these feature spaces, you get let's say, successful solution. If we look just at the top 30 submissions, we see they all come from this part of this map, and not the other ones. And this, for me, was very insightful, because I expected with the prevalence of deep learning, there is, even in time series, of course, we are used to see AI on text, AI on vision, but what about time series? There are time series, foundation models that are like GPT for time series. It's more of a new thing. But for example, this wasn't successful for this class of problem. This is very interesting for me. And so in this last map that I will go a bit briefly, instead, we look a bit into more detail. So what kind of information was extracted from this time series? So we have basic statistical differences, autocorrelation, statistical distribution, linear trends, kurtosis, or median-based measure, and entropy-based methods, spectral entropy methods, interquartile range features. So all possible ways in which you can look at this time series. And once you have all these many views, some of them will help. In some cases, in some kind of structural break problem, some of them are useful. In some others of these descriptors are useful. And so, coupling this representation, this is the representation, this map reflects again all the submission. Mixing this representation together with classification algorithms, powerful classification algorithms, like I said before, gradient boosting, random forest, ensembles of them, you can really extract the maximum from this problem. And differently from the map before, I don't have the slides here, but if we just restrict to the top 30, you will see that the top 30 solution embraces all possible let's say, islands and colors and areas of this map. And one last comment is that when we prepare the competition and the data set of the competition, I'm stressing again that that is, let's say, the most added value that we have, we tune the difficulty so that we expected a score around 70%, because in the end, how accurate you are in detecting whether or not there is a structural breakover of thousands and thousands of time series is what matters. So we expected scores around 70, 75, maybe 80, and instead we were, let's say, quite wrong. The community, by looking at the problem from multiple directions, by submitting so many solutions and trying so many methods, they really outperformed our expectations, differently from the past years. And so we are very delighted to go to the last part of the presentation where we announce the winners.
Yes, and I am extremely happy to be able to present to you the name of the top 10 participants that built the best solution over the last 6 months. And so we have people that are watching the stream from the community, people in the room here. We even have some some participants that made the trip to UAE today. And so I'm going to only show the top 10 because of a matter of time, but let's start today. I'm extremely happy to present you the participant number 10, which is Rakesh Sharupula. Rakesh, felicitations for this amazing score of 86.72%, which is already higher
incredibly high
what you were expecting. And Rakesh is a data scientist from India. He's is participating in a lot of competition. He loves competition. He has, and let me read my notes here, he won 4 gold medals, 3 silver medals, and 71 bronze medals on Kaggle. So this is what we call a competitive mind. He's also, yes, I think we can clap for Rakesh. Felicitations, it's extremely impressive. He's been studying at the National Institute of Technology in Silchar, India. Congratulations, Rakesh. The competitor number 10 is Arina Streltsova. Arina Streltsova is a Russian citizen but lives in UAE. She is a student at Moscow University. She's working on control system theory for electrophysical facilities. So I had to search what it was. And it's studying large-scale experimental or industrial systems like particle accelerators, plasma generator, and fusion device. So she's coming with a very orthogonal profile, right? Someone that is not natively from data science, but that love very complex systems. So congratulations, Arina. I think we can give a round of applause. She reached 87%, so again, really high in our expectation, much higher. Now, participant number 8 is Abhishek Gupta. Abhishek Gupta is a mathematics PhD from the prestigious IIT in India. He reached 87.78%. That's extremely impressive, and he won a prize of $3,500. Congratulations, Abhishek, for your participation. Now, let's move to competitor number 7. Chuan Jihan is a data scientist graduated from the Indonesian Telkom Institute in Indonesia. And he is a data scientist that has been competing in many competitions as well. I am extremely impressed by this score. We go over 88% at this stage. So congratulations to Chuan for this amazing performance. Now, number 6, Leo Nguyen. Leo is a quantitative researcher, so working in finance. He worked at Bank of America, BNP Paribas, and Société Générale, which are prestigious banking establishments. He reached 89.17% with a price of $5,000. Congratulations, Leo, for this great work. Remember that this submission that we are seeing here are the best among 10,000 submissions. So these people have been spending hours and hours for the last 6 months trying to figure out the edge. Now, top 5, Guo Xinguo and Mutin Hong. We actually know these persons. Actually, they were in the top 10 last year, if you remember well. They are coming from China, and they studied at Berkeley, Shanghai Tech University, and Xiamen University. They have been competing in many competitions. They got the 3rd place last year. And they studied life and science. Obviously, they studied AI. And they have also opened, following the competition of last year, I got contacted by Mission and Guoken, and actually they started their PhD on causality research thanks to the work we did last year with ADIA Lab. So I'm extremely happy to have started with you maybe a career in the domain. So thank you for your work, Mission and Guoken. Felicitations, it's just amazing to see you 2 years in the top 5. It's absolutely impressive.
And among of the youngest that we have across the competition, they just finished their master, and they're able to, for 2 years in a row, to be in the top position. So this is, for me, amazing.
Yeah. It's great to have them in the community. And by the way, they started a data club in Shanghai Tech after the competition. So they want to compete more, and they're going to bring more people from China, I hope. Position number 4, Julian Mukaj is a British citizen, reached 89.32% of accuracy. He is also a quantitative researcher. He studied at UCL. He worked in banks like BNP Paribas, Credit Suisse, Goldman Sachs. He's doing NLP and looking at time series. Obviously, as a quantitative researcher, are among the people that spend a lot of time with time series, right? It's kind of the basics of what they are doing. So Congratulations, Julian, for this position number 4. It's a great, extremely good performance. Position number 3, we have a French citizen, Lucas Morin, that is actually living in Paris. He reached 89.59%. He received a reward of $10,000 today. We are in the top 3, so that these people are the best participants among this community. He graduated from the École Normale Supérieure, which is one of the best engineering school in France. He is a former machine learning engineer at the Banque de France. Banque de France is, sorry for this bad French accent, Banque de France, we said, which is the national bank in France. He's lead quant at BNP Paribas. He works on systematic credit model, financial AI, and quantitative research. Actually, Lucas has been part of a community for almost 3 years, and he was also running the quantitative reading group in Paris with CrunchLab, and he's particularly focusing on time series, so this year was really a great year for him. Now, participant number 2, and the second best performance in this competition this year, is Farookan Saglam. Farookan Saglam is a Turkish citizen. He reached 89.85%. He received $20,000 in reward. Congratulations, Farookan. This is an amazing performance. He's a data scientist from the Dortmund University. He's working in generative AI and especially work with generative AI and time series. So how do you apply generative AI to time series? That's been extremely, a new field, extremely useful in that case. And he also collaborates with AI and especially want to focus on climate and how to combat climate change thanks to these techniques. And now, without further ado, I would like to congratulate the best and the winner of this competition on structural break this year. And they actually give us the honor to travel to Abu Dhabi. Guys, if you want to please stand up, I'd like to congratulate you for winning our tournament. Congratulations, guys. And thank you so much for making the trip all the way from Brazil, which is a very, very long flight. It was their first time in Abu Dhabi. Welcome to Abu Dhabi. And so a quick word about this team of amazing professionals. They were led by Humberto Brandao. Humberto Brandao is a PhD in combinatorial optimization. He is also an expert in Kaggle competition. You've been competing a lot. And you have a master. You also did your postdoctoral work at the Brunel University of London. Congratulations, Brandao. Well done for leading this amazing team. I'd like to give a word to Mario and Philo that are also here in the room. They are both quantitative researchers in Alphabet, which is their own company. They are specialized in high-frequency trading, signal generation, and time series modeling, so they know the field very well, and they've been performing great. Now, finally, the fourth member of this team is Raphael Alensar. He's professor and researcher at the faculty. He's professor, researcher, and faculty member at the Federal Institute of Southeast Minas Gerais. He coordinates the Robotic and Technological Innovation Laboratory at UFSG, and is developing research, education, and extension project in artificial intelligence. Together, they represent a rare blend of academic excellence and competition-tested data science skills. You've been competing a lot, congratulations. They have real market and real-world implementation as well, so real knowledge. And they've been performing extremely well. Congratulations, guys. Let's give them a last round of applause. Thank you so much. And now, thanks to these great participants, but not only, we would like to also thank the people that made this competition possible. So people from the ADIA lab, or Simon, Alex Lipton, Professor Marco Lopez de Prado, Emanuele, Patrick, Vincent, Roman, Kuchik, Amélie, obviously, for helping us and to coordinate such an amazing competition. Abdullah, Youssef from my team, Enzo, Grégoire, Peter Cotton, all these persons have been extremely helpful in putting together this large-scale experimentation like every year. I would like to thank them with a last round of applause.
Also the team from ETH, with whom we had two events to promote. ETH is always close to ADIA Lab, and they were instrumental to spreading the word. Bastian Bregman, Carlo Teufel, Cordel Ipax, and many others. Thank you again, and
Thank
that
you.
was all. If you have questions for us after, you can catch up and ask you everything. Thank you again.